back. We're talking about chapter 6. We've been working our way through the algebra sections. So the last topic of chapter 6, the last two sections that you're responsible for are the graphing sections. We'll do section 6.6, which is just the basics of graphing. There's a lot in that section. And then in 6.6, we'll graph systems of equations. Or sorry, 6.7, we'll graph systems of equations. Talk about that. So we got two more sections to go in this algebra, and then we'll switch topics again. So, all right, here we go. 6.6 is graphing, and we're graphing linear equations, so just graphing straight the lines, and they have two variables in it. So when we're graphing a line, we'll see two variables, which is a new thing for us. In the earlier sections, we were doing solving equations with one variable, usually just solving when you had one variable. So we were looking for just x equals a solution. So here we have two variables, such as if I were to say to you, if you're following along in your note packet, think of two numbers, two distinct numbers. So they could be different numbers, just saying. So an x and a y. Two different numbers, two numbers that add to be 7. So asking that question is like saying x plus y equals 7. The question would be two numbers, so it could be two different numbers, so we can't use x plus x, that would be the same, like what we were doing previously. But two different numbers, two numbers that equal 7. And so that's graphing. That's what we get into in this 6.6 section, two variables. So there's a lot of answers to this. If you think of things that add to be 7, you might say like 2 and 5 might be the first thing that comes to your mind. So 2 for x, 5 for y, that adds to be 7. Maybe 1 and 6, 0 and 7, 3 and 4, and I could do this forever and ever and ever. There's actually infinite solutions, infinite numbers when we get into the fractional amounts like a half and 6 and a half. And then there will be negative numbers, maybe -1 and +8. There's infinite combinations that add to be 7. So we make a t-table. Traditionally, we make this t-table to organize the different solutions to this equation. Two numbers, an x and a y, that add to be 7. And so I've got some samples here, like 0 for x and 7 for y. 7 for x, 0 for y, 1 and 6, and then they're vice versas. You might think of other ones too, 3 and 4, then vice versa, 4 and 3. There's no magic to what order we put these in, so it's just a tallying of different ways that we could add or things that solves that equation. Two numbers, x plus y, that equals 7. And then you can see on my example here, I get into decimals. It could be a decimal amount. It could be a negative amount. -2 and 9. So this could go on forever and ever and ever. You could think of different combinations that add to be 7. So the neat thing is, though, if you are solving a linear equation, like you only will be in this section, that's the only graphing we cover. Linear equations, you have two variables. An x to the first power is understood to be a first power, and a y to a first power. Anytime your two variables are just raised to the first power, we're guaranteed these to be linear equations. What that means is the solutions, any solutions that you can think up, will connect in a straight line. They're going to line up perfectly on this graph. All right, so let's talk about this graph. This XY coordinate graph, we consider, it's kind of like having two number lines. The horizontal number line we call the x-axis. And you need to draw this on your paper. It wasn't on pre-sent, probably because I couldn't figure out how to do that in my word skills. But so anyway, follow along. You'll draw this on your own paper. And then your vertical axis is the y-axis. So then we combo these points out and connect our dots. So the first point, we could think of this as an xy point, the point 0, 7. 0 for x, 7 for y. That means on your x number line, start at 0, and then go to y as 7. 1, 2, 3, 4, 5, 6, 7, and dot that in where they meet, 0, 7. So plotting a point. The next one, 7, 0, that's 7 for x, so go over to +7. 1, 2, 3, 4, 5, 6, 7, and then 0 for y, so not up or down for y, 0 for y. 1 and 6, that's 1, +1 for x, +6 for y. where those two values meet. 2 and 5. 2 for x, so over 2 and then up 5 places. Notice how those seem like they look like they're lining up. And that's how it's going to be with graphing linears. They will line up all of our solutions. 3 and 4. So over 3, up 4. Again, perfect. 4 and 3. Over 4, up 3. And we could keep on and on like this, plotting these points. How do you graph maybe this half and 6 and a half? Well, you don't have to be so precise, but we can kind of estimate a half would be halfway between 0 and 1, and then up 1, 2, 3, 4, 5, 6, and then a halfway up. You see how that even fits in with this. And anything I can think of that adds to be 7 will fall on this line. Negative number, here's a negative 1, so back 1 on the number line, and then up 8. And then the last one that I have here, back 2 and up 9. There it is, okay? And I drew this, kind of sketched this on the board, so it's not perfectly drawn with measuring stick or something, but you can kind of tell these line up, right? And if we took a straight edge, connected our dots, when we connect our dots, it says even these little fractional amounts in the middle that I didn't list on these are just some sample points, because I said there's infinite amounts of solutions, but these are just some of the sample ones that we came up with here. But there will be other little decimal amounts between there, and then on this direction and this direction. So we put arrows on that line to show the solutions just keep on going. It could be at negative 10 and positive 17. Negative 107, positive 114. It keeps going and going and going forever. So there's infinite solutions. And then we darken this line in to show every little value along this line is a solution. It's the picture of the solutions, actually. Graphing is a picture of the solutions to your equation, showing it in graphing. All right, now, it's not always quite that straightforward, but before I shift gears and do a harder example where I can't just think of numbers off the top of my head, let's do one more like this. Let's say, let's do a subtract. Oh, I probably should have kept my graph. I'll have to draw that again. Let's say we have, instead of x plus y equals 7, because it could be anything with x and y's in it. Let's say we had x minus y equals 5, for example. Now I'm avoiding putting like 2x and 3y, because then it's harder to do in my head, so we'll move up to that on the next example. But let's say we have an x minus y equals 5. So if you want to pause the video and take a minute, think of some xy solutions, some things that work there, and then see how they look on the graph. All right, so just these, I'm still doing just stuff you can do off the top of your head, like maybe 7 minus 2 is 5. So if I have x is 7, y is 2, that's true. I could do 5 minus 0 is 5. What if I put in 1 for x? Do we know 1 minus what is 5? Could you do that in your head? I'm not sure that that's a good idea. I could just write it down and say, well, if I put in 1 for x, 1 minus what equals 5, that's something I can actually just solve that. We've learned this skill of solving equations. I could take the 1 across the line, minus 1, the positive 1, move it over. But I still have a minus y. 5 minus 1 is 4. Divide by the negative sign. You always have to get rid of the negative sign if you have one on your variable. And then that's negative 4. Okay, let's see if that's true. And it is 1 subtract negative 4, 5. And it is, right? 1 minus a negative makes it plus. So that will work. So you could do things, also use your equation solving technique if it's one you don't even know off the top of your head. What if I put in 0 for x? What would y need to be? 0 minus what? 0 minus what is 5? Well, I can just write that down and do it with my algebra skills that we learned in the last section. So 0 minus y, you can just kind of drop the 0. There's nothing needs to be done there. When you have a 0, you can just let that go. But then I do need to divide by the negative sign to get a positive y equals 5 divided by negative 1. All right, so it's negative 5. So 0 subtract negative 5 equals 5. So this is another way you can come up with solutions even if you can't just think them off the top of your head, because usually you can't do that. Anyway, it's more complicated. So this is a strategy. Just plug the number in that you're picking for x, and then equation to solve to see what y would be. All right, so now I've got 4 sample points. And again, I want to emphasize, these are sample points. They're not the only solutions. I really want to emphasize that there's infinite solutions. These are just some samples that we came up with quickly, and they're very random. You can pick any numbers you want. Sometimes students will pick 0, 1, and 2, just because they're easy numbers to work with. But there's no magical perfect numbers to pick. You just go with what you want. All right, so the first point is 7, 2. So that's x is 7, so 1, 2, 3, 4, 5, 6, 7, and then up 2, 7, 2. The next point is 5, 0, so that's 1, 2, 3, 4, 5, and then 0, we'll keep it on the axis. 1 and negative 4, that's over 1, and then down 1, 2, 3, 4. Looks like they're lining up, that's good. 0, negative 5, 0 for x is here, then 1, 2, 3, 4, 5. Notice those 4 sample points seem to line up nicely, and then we draw that in to show the infinite solutions that would be involved. Everything along that line, every xy coordinate on that line onto both infinities would solve that equation, the picture of the solutions. All right, so now let's go up to the next idea that you see on your paper. And so I've noted here, what if instead of these that are kind of easier, maybe you can think of off the top of your head, what if we were trying to do 2x plus 3y equals 6? Now that's a little harder for me just to come up with some solutions, some xy solutions that work for that. So usually we don't. Usually we don't just figure them out off the top of our head. We use a strategy of plugging numbers in for x and figuring out what y is, or we can plug in for y and figure out what x is. But I mean, if you know some solutions, by all means, you might think about it. If I did 2 times 0 plus 3 times 2, notice that works. So 0 for x and 2 for y is a solution. So you might kind of think through some of them like that. But typically, we use this strategy. You can see on the next page of organizing a t-table and picking numbers for either x or for y. Like I said, a lot of times students will do 0, 1, and 2. But there is no magic in that. You pick whatever numbers you want. So, in your example on the second page, I chose to do x is 1. So I subbed in x is 1, and then I had to do some figuring out. If I plug in x is 1, it's going to look like 2 times x is 1 inserted. And then I have to do some equation solving. 2 times 1 is 2. Then I minus 2 from each side. Then I have to divide by 3. And I get a solution that is a fraction. That's not as fun, right? We want to avoid those when possible, but fractions do happen. So how am I going to graph that? Well, it's not as easy to graph because you don't want to have to break out your measuring tape and everything to do these. And if you do it on the computer, sometimes it's not calibrated to do a fraction. Even though this is a valid solution, sometimes the computer won't intake the fraction ones if it's not set up to do so. So I might just say, hey, I don't like fractions. Let's shop for another point. Let's put in x is 0 and see if this goes a little kinder. So when I plug in x is 0, we kind of already talked about that and noted that 2 times 0 plus 3 times y, we can solve that. 2 times 0 just zeroes that out. Then we divide by 3. Y is 2. Oh, that's a nice point, a very crisp, plottable point, 0, 2. We could also plug in on the y side. So the next thing I do, I could keep plugging in on the x side. I can also plug in on the y side. So I do that next to demonstrate. Start the equation over. 2x plus 3 times 0 equals 6. So you can equation solve that. The 3 times 0 wipes that out. Dividing by 2, x is 3. And you can keep doing this, like I said, forever and a day till you plot. It really only takes 2 points to connect, but it's a good idea to have 3 just because you can kind of check on yourself to make sure they truly lined up, and you catch an error that way.